Lift and Move USA.
Okay, thank you. Number one, I want to welcome you to our station, Engineering and Data Capture Technologies. We are really the tip of the spear as far as what you're going to see here today. You've got trains that are outside, a variety of different material testing that's being done, heavy haul. We're the guys that get in ahead of everybody, examine the ground to make sure that the trains are actually going to stay up. Heavy haul stays up. We also capture the environment in which these are going to work. Be able to check dimensions, make sure that all of the, this is great with the horns coming up, to make sure that this equipment is actually going to be able to fit. So it's to be able to make sure that the folks that are out there are going to be able to execute the work that's being planned. I'm Mike Walsh. I'm the company president. Joining me today, I've got my son Brian. Also with us, Chris Munwam. Chris is the head of our non-destructive examination group, primarily focused on concrete. The use there, it's in advance of any cutting or coring that's being done. And also for this application where we've got heavy haul or we've got heavy equipment being set up, to be able to examine the concrete and make sure that it's going to be structurally sound to be able to support what the loads that are going to be imposed on it. Butch Tucker, who is in the center standing behind one of our GPR systems. Butch is an expert in 3D laser scanning. And that's an instrument that's a little blue box that you see sitting on the tripod. It's also about a $55,000 investment that it'll take a photorealistic, looks like a photograph, full panoramic. Each pixel in that photograph, though, has a discrete XYZ coordinate associated with it. We're able to take that image, take that data, pull it into a CAD environment, be able to model from it. So we're able then to determine whether crane's going to fit, boom swing's going to work, tail swing's going to work. They can get the load in, a variety of different things. It's also used for engineering design. Biggest thing out of this, it's the opportunity that you have in front of you. It's not a job. This is a career path. This is a chance that you have to be able to set yourself up basically through the rest of your life, whether it's for one company or for multiple companies, but it's in this industry, the ability to be able to get it and build a great, I apologize for this, there we go. There's a boost in terms of right now there's a tremendous demand as far as the need for construction help. And this is both on the, here, you can take a look at this real quick. This gives you an idea of the hire data. These are the openings that you're seeing track across the top and the hires on the bottom. So those are the actual jobs that are being filled. So that gap is your window of opportunity. And that gap is only getting wider. Those are good paying, honorable jobs that are available now. You need to develop the skill sets, and they're going to be there for the foreseeable future. So again, think about this. Basically, the opportunities here fall into two camps. You've got craft labor, or the building trades. That takes in operating engineers, iron workers, millwrights. I'm actually a pipe fitter by trade. I have a degree in civil engineering as well. That's how I put myself through school, was working the trades. So you've got that end of it that's more physical, more the actual installers, the execution guys. On the other side is the professional, more the professional arena. And these are project managers, estimators, field engineers, design engineers, surveyors, and then specialty technicians like our fellows are that you have a lot of training in terms of flying drones, operating radar systems, the laser scanning, the interpretation of the data. All of that's without a college degree though. So you can see there, the need is enormous. Right now the present administration is talking about spending $1 trillion on infrastructure, and it's desperately needed. We've got bridges that are failing, utility systems that are failing, roads that are rotted out, buildings that are in desperate need. So there's a lot to this that there's a big opportunity. To give you, again, a little background of who we are, we came out of a traditional design role We're a 65-year-old company, but we've adapted to the technologies that are out there and the change in demand. And the opportunities, this isn't the old days of construction where it was basically pick, shovel, mule. You know, now there's a lot of technology. You'll see this as you go around. You take a look at the simulators that are there. You take a look at the actual cranes and equipment themselves, and the technology that's built into this equipment is, I mean, it's incredible. It's breathtaking as to what's going on. And it's a huge improvement. So these, again, are just some of the survey tools that we use: ground penetrating radar, electromagnetic induction. We utilize this for a variety of applications. Obviously, this, I don't know if you're aware of it or not, but this is National Safety Week too. There's a big reason. Don't worry about that. They're breaking chains over there. Actually planned, so you'll get to see that a little later. But this actually occurred down in the Chicago Loop on Garland Court. It's an alley between Michigan and Wabash about 10 years ago, and this is what we're there to prevent. It's to be able to determine the conditions and keep people out of these kinds of problems. Mapping the utilities and infrastructure is something else that we do. This is a little bit of an exaggerated photo, but you know, there's a very crowded underground environment. And again, we're there to try and map this, prevent outages, and prevent people from getting hurt. Concrete, non-destructive examination of concrete to be able to map what's embedded in the concrete. Laser scanning, as we talked about. And this is actually what you're seeing here. That's not a photograph. That's what's known as a point cloud. Every pixel in there has a discrete XYZ coordinate to it. That's how we can take all of this information, pull it over into a CAD environment, model cranes, model other equipment, bring this in and be able to determine what's going to fit, what doesn't fit. It's a precursor for the actual engineering design, and it's huge on the construction side in terms of being able to make sure that you actually can execute the intended design. It's gone from terrestrial scanning, or kind of stop and stare or standalone, which is what you've got here, to mobile scanning, where you can put these scanners now on a vehicle, drive at virtual highway speeds, and capture that same point cloud data to be able to do. And for us, it's huge, because if we're doing clearance studies to try and bring these big vessels, these huge transformers through an area, to know whether the wires are in the way or street lights are in the way or whether the vehicle can make a turn, it's all critical to us. And then, again, these are some of the other technologies that are at play. Everybody's seeing these today. In fact, I don't know where he is, but you had one buzzing over your head while you were standing around a little earlier. We use it for, again, inspection of cranes, documentation of existing conditions, and there's now the technical capability to be able to take a digital photograph, or video in this case, and actually export that into a point cloud environment. So you get the equivalent of what you get with a laser scanner, but you use a drone and a digital camera, and you get basically the same information. And again, now we're able to model it. So in terms of accessible areas, being able to cover wider areas, to be able to use UAVs, again, huge technology breakthrough for us. Where do we work? Well, basically everywhere. What you're seeing on the left, that's actually the 1.5 million gallon cistern at O'Hare Field that they're putting a concourse expansion over the top of. We did the structural inspection of that, documented the conditions. We're going to be back in there at the end of the year after the construction's done to re-inspect it and make sure that there was no damage. Every drop of water that goes to O'Hare Field goes through this 1.5 million gallon structure. The upper right, that's part of the Chicago freight tunnels. And you may or may not be familiar with those, but there's a network of tunnels that are under almost every one of the streets in the Chicago Loop. A number of years ago, most of you guys are too young to remember the flood, but there was a breakthrough. One of the tunnels actually was cracked at the Chicago River, flooded. There was like a $2 billion damage amount of damages in terms of downtown buildings. The basements flooded out as a result of water coming through these tunnels. We've been down there, documented those conditions. And then this is the roof down at the State Farm Center in Champaign. So we do rope access work and a variety of other things. So anyway, thank you very much for your attention. If you have questions, interest, please stop back. We'll be here. Have a great morning.
Lift and Move USA.